Hello students, first revision of last class. What we are learned in last class. In last class we have discussed about Newton's second law. Newton's second law. What is the mathematical expression for the Newton's second law? F equal to ma, where m is mass and a is the acceleration. If suppose you are increasing mass of the object, if you are increasing mass, we need to apply more force. If you are decreasing mass of the object, we need to apply small force. So mass of the object is increases, we are applying the force is also increase. If you decrease the mass, applying force is also decrease. So mass of the object is directly proportional to applied force on the object. Next to acceleration. If you are increasing acceleration, we need to apply more force. If you want to decrease the acceleration, we are going to apply small force. So force is depending on the mass and acceleration. So force F is directly proportional to ma. So from that we are derive the mathematical expression for the Newton's second law, F equal to ma. In case of second law, unbalanced force or act on a body. In case of second law, unbalanced force are acting on a body. Okay. Next, what is the statement of Newton's second law with help of momentum? We are already discussed that the rate of change of momentum is directly proportional to external force acting on a body. The rate of change of momentum. The rate of change of momentum can be written as dp by dt is directly proportional to F. That is the statement of the Newton's second law by using momentum. Next, what is the relation between Newton and dyne? 1 Newton equal to, we can write 10 to the power of 5 dyne. So 1 Newton is equal to 10 to the power of dyne. This is all about Newton's second law. Now we are going to discuss about Newton's third law. Newton's third law. In Newton's third law, what we are going to learn? For example, this is a wall. I am taking an object of mass m. This mass of the object is attached to one end of the spring. This is the spring. The other end of the spring is connected to wall. When I am applying the force on the object in this direction, this object is going to move this direction. When you apply the force on this object, internally same force is acting towards the wall with the spring. Here this is the external force. We are applying the external force on the object. In same situation, in case of the spring, same force is acting on the wall. So here two types of the forces are acting. I am taking, this is the force F1, this is the force F2. F1 equal to F2, the magnitudes of both forces are same, but they are moving in opposite direction. So F1 is equal to minus F2. F2 here acting opposite direction of the force. This is the one example. Next, second example, I am taking two magnets. Bar magnet. Every magnet consists of the two poles, north and south. This is the another magnet of south and north. Here north pole of the magnet, here south pole of the magnet. If two unlike pulses are brings together, what happen? Attract each other. So when you are bring these two magnets together, what happen? Attract each other. So this magnet is coming towards the other magnet with force of F1. Similarly, this magnet is also moves toward the first magnet with force of F2. Here magnitudes of the both force equal each other, but they are acting in opposite direction. Here both force of magnitude is equal, but direction acting of the force direction is in opposite direction, that is indicated with the help of negative. Okay, so F1 equal to minus F2. Next, third example, I am taking two spring balance. This is the first spring balance. This is the second spring balance. One of the spring balance is attached to wall. Next, the first spring is attached to second spring. This is the spring name B, this is the spring name A. So here I am applying the force on the spring A. If I am applying force on spring A, you will notice that in case of spring B reading, in case of spring A reading, both should be same. Here also shows 2 kg of mass, here also shows the 2 kg of mass. For example, if you are increasing the force on the spring A, it shows the 3 kg. In spring B also shows the 3 kg of mass. So what we are observing? We are applying the force on the spring A, it exerted to force on the spring B. Similarly, the force, instantaneous force acting on spring B to spring A, with the help of these forces, both springs will shows the same reading. From the above three examples, what we are understanding here? When one object exert a force on another object, the second object instantaneously exert force back to the first object. When one object exerts a force on the another object, we are already seen the spring example. We are applying the force on a spring A, that force is exerted by the spring B. The second object instantly exert a force back to the first object. we are applying the force A to spring B, immediately the second object means spring B instantaneously exert force back to spring A to the first object. That's why the spring shows same reading. Here both forces have same magnitude but opposite in direction. Here both forces have same magnitude but moving in opposite direction. F1 equal to minus F2. Suppose this is a object 1, this is the object 2, this is A, this is B. Here I am applying the force B to A, here I am applying the force A, B. So when you are applying the force on the object A, FBA is equal to force acting on the object B, FAB. Here magnitude of the force is equal but they are acting in opposite direction. FBA equal to minus FAB. If suppose both bodies having equal mass M1, M2, object is M1, A1, next second body is M2, A2. M1 by M2 equal to A2 by A1. So M is inversely proportional to A. If you increase the mass, it produces the acceleration is very low. If you increase the acceleration, it produces the mass is very low. This is the relation between mass and acceleration of the object. If you are observing car and lorry, car of the mass is very low, it produces the acceleration is very high. If you are using the lorry, the mass of the lorry is very high, it produces the acceleration is very low. So mass of the lorry is high, it produces the acceleration is low. Car having mass is very low, it produces acceleration is very high. So car having high acceleration, lorry having low acceleration. So from the relation what we are understanding, heavy objects can produce small acceleration, small objects can be produce heavy acceleration. Now we are applying the force on the object 1, force is BA. This is the applied force we called as the action. If you are perform the action, then due to this action in this ball produce the force is FAB, that is reaction. You are applying external force on this object that will taken as the action. Due to this action in this body produce the force FAB, that is the reaction. Action, reaction both are in opposite direction. Here action and reaction both are acting in different bodies, not in single body. Action and reaction both are acting in different bodies. So here action and reaction same but they are acting in different bodies. So what we can write on as Newton third law statement, every action there is equal and opposite reaction. Here action and reaction will acting on different bodies. This is the Newton third law statement. Every action there is equal and opposite reaction. Here reaction is equal, but this reaction is acting in opposite direction. Here action and reaction will be acting on different objects or different bodies. This is the statement of the Newton third law. This is called Newton third law. We can say that F1 equal to minus F2, where F1 is action, F2 is the reaction. Next, applications. Newton third law. First application is fire a bullet from gun. This is the first example. Fire a bullet from gun. For example, this is a gun. If you want to fire a bullet from the gun, what we are doing? Apply the force towards the gun. We are applying the force towards the back side of the gun, then immediately bullet will move forward direction with the exact force of a gun. Understand? When you fire a bullet from gun, we are applying the external force on the gun. This is a one force. This force is acting towards the gun. Due to this force, the bullet is moving forward direction with same force. This is I am taking force F1, this is I am taking force F2. F1 equal to F2, but both forces are moving in opposite direction. F1 equal to minus F2, where F1 is action performed on the gun. Due to this action, reaction force is F2 performed by the bullet. So F1 is the action, F2 is the reaction. Here action and reaction are performed on the different bodies, but action and both reaction are equal in magnitude, but they have different in direction, which produce large acceleration. So here gun, mass of the gun is very high, mg, very high while compared to bullet. So this is the mass of gun. Ma is the mass of, mb is the mass of bullet. Okay, so mg is greater than ma. Mass of the gun is greater than the mass of the bullet, mb. So acceleration of bullet, acceleration of the bullet is greater than the acceleration of gun. We know that already relation between mass and acceleration, m is inversely proportional to 1 by a. Mass is increased, its acceleration is decreased. So mass of the gun is increases, it produces the acceleration is very low. It is just applying the small force towards the gun, while mass of the bullet is very low, it produces the large acceleration a b. So acceleration of the bullet is A, B. So gun produces the low acceleration, that is Ag. Bullet produces the large acceleration Ab. That's why bullet is moving with large acceleration, because its mass is very very low. This is the first example. Second example is walking on a road. You have observed that while walking on a road, one person is walking on the road. While the person is walking on a road, compared to two legs, one leg is applies more force on the ground first. Suppose I am taking this leg. When you walking on the ground, first of all you will apply the force on the ground. First this leg, that is F1 force. Due to this force, second leg will move forward with the help of force F2. So F1 is the action. You are applying the force towards the ground. Due to this action, F2 is reaction. The person will move forward direction. Here also F1 equal to F2, but in opposite direction. Here action and reaction are acting on different bodies. Okay. So F1 equal to minus F2. Without action force, there is no reaction force. Third one is motion of rocket. Motion of rocket. This is a rocket. When you placing on the fuel in rocket, these all fuels going to burn. Those fuels release exhaust gases that will taken as the force F1. We are placing in rocket some fuels. When you burn the fuels, it release the exhaust gases with the force of F1. Due to this force F1, here rocket will move forward direction with force of F2. So when you increase the force F1, if you are releasing more exhaust gases, the rocket will move more force. So F1 equal to F2, both magnitudes are equal, but they are acting in opposite direction. Here force acting downward direction, motion of the rocket is in upward direction. So both forces are in opposite direction. F1 equal to minus F2. Here action is F1, we are burning the fuel in rocket. Reaction is motion of rocket with the force of F2. This is the reaction. Due to the action, the rocket will move forward direction. Due to this action, the rocket will move forward direction. In every case, what we are understanding? Due to the action force, reaction will be performed. Without action, we can't produce reaction. One more point here. Action and reaction must be acting on different bodies. Okay. So what we are understanding? In nature, every action there is equal and opposite reaction, that is called Newton third law. F1 equal to minus F2. This is all about Newton third law with applications. We'll meet in next session.
Subscribe now and press the bell icon. Never miss an update.